Okay, I think we're started. Okay, I'm not going to do tons of stuff with linear equations. Hopefully you remember that. If you need me to make extra videos, just let me know. So one thing I do want to talk about, though, is a secant line. The word secant, think of second, it goes through 2. A tangent line just crosses at 1, okay? So if you have a parabola here, this would be a secant line. It goes through 2. If I had just 1 point on here and I drew a line that only touched at 1, that would be a tangent line, okay? And so I'm going to, just to kind of help review a little bit with equations, we're going to try to find the equation of a tangent line because that's an important skill in pre-calc. So if you need more additional review to that, we can. All right. So first of all, we have our parabola up here, and I put the function over there, and we are going to draw a line through 2 points. Okay, so I'm going to, let's see, what do I want to use? So we're going to find the rate of change. Remember, that's just a fancy word for slope, right? The rate of change from -2 to 1. Now, again, these are inputs, right? So if you think of an input-output table, right? I am giving you inputs, and I want you to find the outputs so that we can find the rate of change. Okay, so again, we're going to come over here to our function, and we're going to sub in these values, right? So let's sub in a -2. We have, oh, you can't see me over there. I'll move over here. We have 3, and then what? We have -2 squared minus 2 times -2 plus 3. We're just doing input. Again, you can type that in a calculator and get your output. What do we have? This is +4, so 12 plus 4 plus 3. What is that? Is that 19, I think? You guys can keep me honest. Email me if I'm wrong. That would be helpful. All right. Then let's do the same thing. Now we're going to put in or sub in the input of 1. So we have 3, 1 squared minus 2. Our input is 1 plus 3. So again, we put input into a function, we get output. Again, you can just type this on a calculator, hit enter. All right, you don't have to do this, but this would be 1 times that is 3 minus 2 plus 3. So I believe I got 4 for that. Hopefully that's okay. All right, so now I have my input and my output to my function. Again, you can do y2 minus y1, all that. I like to do change in y over change in x to get my rate of change or my slope. All right, so what's happening here? This guy is going down by 15. So my y values, my output, change in y, and you can't see that. I have to get used to the size of this thing. All right, so -15. All right, and then my change here, -2 to 1, is going up by 3. So if I divide that, I get a -5. -15 over 3 is a -5. That is my slope or my rate of change. So if I'm just asking you the rate of the change, you're done. Okay. Now, what we want to do is find the slope of the line that find the equation of the line that goes through those 2 points, okay? And so to do that, we need y equals mx plus b. Part of that is your m, rate of change, slope, we got that. But then we also need the y-intercept. We need that second part because not all lines go through 0, 0, right? They're shifted. And obviously if this one went through 0, 0, that would be kind of hard. So we need it, probably up in this range. So I'm going to pause for a second. I'm going to plot. These are our 2 points. I'm going to plot them so we can see where we want our line to go. And then we'll focus on trying to find the equation of that line. All right, I'll be back in just a second. I'm going to pause. Okay, I'm back. So in the previous section we just did, we found our input and output, right, which were the 2 points. I labeled them here in Desmos, and we know the slope. So what we want to do, and again, I don't know how well I can do this, but I want to graph. Oh boy. I'm looking at a computer screen trying to draw this line. So if you're like, why is it so hard because I don't really see it. But anyway, pretend this is a line that's straight, right? And it's going to go through those 2 points. Now notice it does have negative slope, which makes sense. It's going down. All right, how do you find an equation line? I like to do y equals mx plus b. Some people like point slope. My experience with point slope is nobody remembers it. So they leave class and they're like, oh yeah, how do you do that? Everyone remembers y equals mx plus b. So I am a huge fan of that. All right, so here we have our function. We have y equals mx plus b. What do I know? Well, I know my I don't know, sorry, I need to know my y-intercept. But what do I know? I know 3 out of the 4. And if you know 3 out of 4 variables, you can solve for the other one, right? So I know my m, my rate of change or slope. And I actually know 2 inputs and outputs. I'm just going to pick one of them. I'm going to use these because less likely to mess up. There's no negatives here. So my input is 1, and when my input's 1, my output is 4. Okay? And then plus b, and notice I can solve. So I have an algebra equation here. How do you get rid of minus 5? Again, inverse, and b is 9, okay? So when you have m and b, you can write an equation of a line, all right? So the equation of this line is going to be y equals, sub in your m, and you have your b, and that's my equation, all right? So I'm going to pause, and I'm going to go ahead and type that in. Well, actually, I can just do it now. It doesn't take that long. All right, let me just type it in. So y equals, what do we have? Negative 5x plus, what is it, plus 9? And that should be better than what I drew. All right, and does that go through our 2 points? It looks like it does, so that's good. So I know I got my answer right because I can check it. Now, sometimes what we like to do is we like to drag this point closer and closer and closer and closer and closer, and we actually want to try to get a tangent line sometimes, or sometimes we're on the same side. So maybe I might do an input of 2 and then get it closer and closer and see what happens. Okay, so I'm going to pause. Let's go ahead and try to find a secant line through 1, 4, and then 2, whatever it is, and then see if we can get that. So I'm going to pause here and let's try to do that process. Where am I at? There we go. All right, so now we're going to do 2 different points. We're going to keep the 1, 4 because we already have that. Let's sub in 2. So again, anytime you have input, if you're like, I don't know what to do, subbing it in is always a good idea because functions have inputs, they have outputs. I'm going to sub 2 into that original. So 3, and again, I tend to write off the glass. I apologize, still getting used to this. 3, 2 squared minus 2 times 2 plus 3. So I'm subbing the 2 in everywhere I see next. Again, you guys can just type this in. This is what, 4, what is that, 12 minus 4 plus 3, what is that? Is that 8 plus 3? It looks like that's 11. Okay, and I'll know if I make a mistake in a little bit. So eventually we're going to find the secant line between these. Right now we're going to try to find the rate of change because I need to know my slope first before I can do anything else, right? Because that's how it's changing. I need to know how it's changing. All right, so here we have input and output. Every function has input and output, 1, 4, and what, 2, 11. Okay, so change in y is what? It's going up by, is that 7, I think? Okay, all right, and then change in x is just going up by 1. So now it looks like the slope is a positive 7. So this time it's going to be going this way. All right, and I can plot that other point. What is it, 2, 11? Parentheses 2, comma 11 into parentheses, and then I can label that. All right, so we're trying to find the line that goes between those 2 points now, positive slope. All right, so I'm going to write m equals 7 over here so I don't forget. All right, so again, if you want to do point slope, go for it, but again, most students forget it, so I don't like to teach it that way because long term, it doesn't really stick in your long-term memory very well, which is when you're in calculus, that's the whole goal, right? So I like y equals mx plus b. Anytime you're trying to find something, look at what you know, what you don't know. I don't know the b, right? That's my whole goal. What is my y-intercept? It doesn't go through 0, 0. So I know my slope. I know actually 2 inputs, and I knew 2 outputs. I just need one of them, okay? That's all I need. So sub in what you do know to get what you don't know. I don't know, let's use 211 this time. It doesn't matter. Input is 2, output is 11. My slope is what, 7? And then again, a linear equation, isolate an inverse, subtract 14. Again, I think money debt, I owe what, $3 is B. All right, so I think my equation is y equals, my slope is 7. And so that's my function, right? That will create infinite many points to graph on this line. So I'm going to type it in. So let me go to Desmos. And y equals, what do we have? And you can use f of x, y equals, doesn't matter, 7x minus 3. And it looks like it goes through there, which is good. Okay, so what happens if, again, I get infinite close to this, right? Then I could try to find what we call the tangent line. But the problem is, how do we go about doing that, right? And so we have a nice little thing that we use to figure that out. But from a math point of view, for now, I could say, okay, well, what if I do 1.0001 and see what my output is, and then try to find the equation of line there and slowly get closer and closer and closer and closer. But again, we want kind of the instantaneous rate of change, like that moment in time. Like, what is it at that moment in time if I can slowly bring those together? So let's go ahead and do the same thing we've been doing, but we are going to have the point be, let's do, 1.001 and slowly get in there. So we're going to ditch this point. We're going to try to find this one. So again, I'm going to pause. I'm going to do a little bit of the math just for time-wise, and then I'll explain it. Okay, all right, let me explain what I did. I subbed in our new point, which is very close to 1. Subbed it in here. There is a +3 over there that you can't see very well. So there's a +3 there. All right, subbed it into my calculator, got an input and an output. So I wanted this input, subbed it in to get the output. Found the slope, change in y over change in x. So this went up by 0.004003. This went up by 0.001. Divided, got a slope of that, okay? Sub into y equals mx plus b. I know 3 of the 4. I know input, output, and m. I subbed in the easier input and output because I'm kind of lazy. Subbed in input, output, and my slope. Solve for b by doing inverses. So now I have the 2 required things to write a linear function, okay? And if you write y, or if you call it f of x, doesn't really matter, okay? Same notation. All right, so here you can see my 2 points, but they're so close together, I can't really tell if my line is going through them or not. So I am going to zoom in. So I'm going to zoom in, zoom in, zoom in. I can keep zooming in. All right, and there, that's what we would call a secant line. Now, it looks like it's almost, you're like, well, that's almost a tangent line. It's a secant line. We're still going through 2 points, but there is a way that we can find the instantaneous slope at a point, okay? And I'll make a video on that later. But hopefully you can see that indeed, if I keep, that my line does go through those 2 points. So hopefully that helps you. That's just a quick review of finding an equation line, but given a context that we're going to use in pre-calc. So hopefully that helps.